It's our second flavor of subnetting now. Subnets based on host requirements rather than network requirements as we did in the previous nugget. So, just like the previous nugget, we're jumping straight in the water with 4 unique examples. Now, this first example looks the same and feels the same as the first example we saw in the last nugget. However, there's a major twist to it that makes it different. Notice, this organization has purchased the Class C address 216.21.50. So immediately I think /24. That's the Class C subnet mask. And would like to create networks of 30 hosts each. Ding, 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 ding. That's the unique twist. So in the previous nugget, we said, how many networks do we want for this? And we counted them up. We said, okay, 1 network, 2 networks, 3 networks, 4, and 5. And so we figured this question based on 5 networks and kind of broke up the subnets to fit each one. Now, this one, we've stated the question a little differently. We've said, well, honestly, my main focus, let me put it that way. My main focus is not on how many networks can I get. My main focus is that I need networks of 30 hosts each because my offices, that office has 20 people, that office has 28 people, that one has 15 people. So I really want to create this so it fits my offices. So the offices will have 30 usable IP addresses that they can use per office. The good news is that the process is almost exactly the same as it was previously. So let me quantify almost. So first off, I've written up our number again up here. 216.21.50 is the network, and we wanted 30 hosts per network, right? So 30 hosts per network. So step 1 is determine the number of hosts and convert to binary. So we started with 30 hosts, and we'll write that as a binary number. Now this is the same as it was previously. It's just it said convert the number of networks to binary. 4, 2, 1. So we'll do 30. So that'd be 0, 0, 0, 1. So 30 minus 16. I know there's the shortcut, but we're going to do it the long way to start off with. 4, 14. So 1 minus equals 8. So that'd be 6, right? 1, 1, 0. So the binary equivalent of 30 is 0, 0, 0, 1, 1, 1, 1, 0. Good. Okay, step 2. Reserve bits in the subnet mask and find your increment. Now, we're back to that Class C network, 255.255.255.0. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Is that 8, right? Yep, 1, 2, 3, 4, 5, 6, 7, 8. Good. Now, here is where the twist comes in. Here's where the almost the same comes in. Now, previously, I kept asking the question, okay, are we after networks or are we after hosts per network? And the answer in the previous nugget was always networks. We're after networks. We kept emphasizing we're after networks. And network bits were the ones, right? We were saying, okay, well then let's put ones here and stretch it out this way. Now that all changes now. Because instead of saying I'm after networks, I'm after hosts per network. Now, keep in mind, I'm still subnetting. It's not like I'm moving those ones backwards or anything like that. I'm still subnetting. However, my main focus is not how many networks I get. It's how many hosts per network I get. So what I'm going to be doing is saying, instead of looking for, and we've got to identify, it takes 5 bits to get the number 30. Right, just like we saw in the previous nugget. So instead of saying I need 5 network bits, because that would be the previous style, is saying I've got 30 networks that I'm after. No. I'm saying I can't get the number 30 with any less than 5 bits, so I need to save 5 host bits. 1, 2, 3, 4, 5. Did you notice what I did there? Two things. One is save the 5 host bits, but also did you notice the direction I was going? Instead of going left to right, like I did with the networks, I went right to left. Because that's where my zeros exist. That's where the client bits are at. So I'm saying, as long as I have 5 bits, I know that I can get the number 30. Okay? All the other ones, I don't need for the clients. I've met my requirements. I can get my 30 hosts with my 5 bits. So the rest of them can go to the network side because, guess what? I'm still subnetting. right? This is still subnet. I'm still breaking one network, which was 216.21.5, into multiple subnetworks, but I just wanted to make sure that those subnetworks, however many I get, will have at least 30 hosts per subnetwork, right? Okay. Everything else is the same. That's the story. My focus is on the zeros. So now let's figure the rest of this out. It says so we've changed our subnet mask. We know what it's going to be. It's 255.255.255, and then this is the last octet, so it'd be 128 plus 64 plus 32. That'd be 224. Or if we're using CIDR notation, we just moved from a /24 down to, we added 3 more, so that'll be a /27. Again, just these are 2 ways of writing the subnet mask. That's it. No other concepts in that. Now, the increment is still the lowest network bit converted back to a decimal number. That would be 32. Right? Lowest network bit is a decimal. And by the way, when we're figuring out the number of hosts, if this number is ever less than your host, be concerned. Because that really defines the ranges. How big are they? So now I can come down here to figure out my network ranges. 216.21.5.0 is where we begin, and then we just start adding our increment in the third octet. You see how everything else is the same? 216.21.5.32. 216.21.5.64, and down and down we go. 96, 128, and this would continue on down off the screen. Fill in the end ranges. This goes to 216.21.5. What's the last IP address? 31, right? 216. Also realizing that we can't use that broadcast address because last IP address, because it's a broadcast. So we actually have 1 through 30. We have exactly 30 usable hosts per sub. Just one of those weird values that happen to land on the exact amount. But we would just continue this trend all the way down, filling in the network ranges. Awesome. So again, the slight tweak that we get is right here in this second step, to where we're no longer focused primarily on adding ones. We're focused on saving zeros. I was teaching a class one time, and we were trying to figure out, this was long, like when I had first created the subnetting method, and we were trying to, and somebody was like, how do I remember that? How do I remember when I'm going right to left or left to right and ones and zeros, and I was like, I don't know, how can we remember, guys, to save the host bits, and this guy from the back, he was totally random, he yells out, he goes, save the hosts, and we all kind of looked at him, we were like, what? And he goes, well, it's kind of like, save the whales, like save, save Ferris. It's like we have to save the host. So that became the theme from there on out. Is anytime we saw one of these examples, I'm like, okay, are we trying to add more networks or save the host? And everybody in the class would yell out, save the host. It was kind of fun. And so I have been teaching in classrooms for a long time this subnetting method, and it was funny because my wife actually went to one of my CCNA classes early on, so I can say she's a CCNA sort of, just because she attended the class, and so I took her with me to Cisco Networkers. This was maybe 5 years ago. It was before kids, BC, when we could do that, and so we were there, and she was at this big event with me, and we were just a ton of people, just crowds and crowds of network people at Networkers, and there was a guy who from across the room goes, save the host. And it was funny, my wife looks at me and she goes, someone did not just say that. And I was like, where is he? Where is he? My brother, and then, so it was funny. We searched, and I was like, hey, it was just a guy that had been in one of my classes long ago. So anyway, this save the host thing has been around for a long time. So I'm going to use it. I'm going to keep saying that when we're going through these examples. Okay, example number 2. We've got class C address again. Same story, 195.520. And we're going to need 50 hosts per network. So a little larger organization, 50 hosts per network is what we're after. All right, so let's go. I've got 50 is my magic number. I'm looking for how many bits to get the number 50. 64, 32, 16, 8, 4, 2, 1. So I'm going to go no, yes. Now I'm going to start invoking shortcut number 1 right here. I'm going to say, okay, I can stop because now I know it takes 6 bits to get the number 50. And I'm looking, that's an easy one, right? That's 48, 50. Yeah. So, but nonetheless, it still takes 6 bits to get the number 50. So now I look, it's a class C. So let's do this. I'll do /24. And again, I'll start showing you now. We've seen a few of these. Let me give you some shortcuts that I do when I'm writing it on paper, like on a test or something like that. What I'll do is I'll say, okay, /24. I know that's 24 ones. I know that's the first 3 octets. So when I'm used to seeing it, I'll go 111 dot 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 111 dot 0, 0, 0, 0, 0, 0, 0. I always write the zeros. 0. Because that's our playground. That's where we get to work. So essentially, it's, again, if this messes you up, don't do it. But that's what I do, just so I don't have to write all 3 octets. This represents 24 bits, right? 24 ones split between the first 3 octets of the subnet mask. So what I'm focused on is the zeros. Now, again, back to my scenario. Are we creating 50 networks, or are we saving 50 hosts per network? Save the host! We all yell, hands in the air. So we're going to focus instead on saving 6 bits. 1, 2, 3, 4, 5, 6 must remain 0 because I can't get my 50 hosts with any less than that. And then shoop shoop, those 2 can flip over to 1 because I'm still doing my subnetting. So now I've got my new subnet mask. It moves to a /26, or if I wanted to write that in decimal, it'd be 255, 255, 255, 192. That'd be 128 plus 64, right? So the lowest network bit converted back to a decimal is 64 in this case, which makes me feel warm and fuzzy because I'm looking, okay, I needed 50, I got 64, right? So I'm going to come down here and let's use that increment, 190, not 192, 195. Oh, and be so careful. I've seen on Cisco exam. I don't know why Cisco does that. But for instance, everybody's used to private IP addresses like 192.168.1.0 and all those kind of things. Cisco will have a simulation on their exam where they're like, okay, go ahead and assign the IP address 192.186.1.9 to that interface. I don't know why they do that, because it's so, like, you see that and you're so used to seeing this that you automatically transpose them when you type, and then you assign the wrong address. But maybe they're just like, we want to make sure you're really reading the question. But nonetheless, 195.520.0 is where we're beginning. It's in the 4th octet, so I'm going to do 195.5.20.64. And I'm going to take this one all the way. 195.5.20.128.192. Now, what happens if we add 64 to 192? We get 256. Again, just like the last nugget, don't panic. It's okay. That just means you're done. So I'm going to fill in the end ranges. This goes through 63, 127, 191, 255. So what does this tell me? This tells me that when I'm getting networks of at least 50 hosts per network, I can only get 4 networks out of a Class C block. I just simply run out of IP addresses if I try to go more than that. So that's good. It meets my requirement. And it also gives us a chance to go back to that formula. Remember that? 2 to the power of bits. So I'll say, if I'm curious about the networks, I'll do 2 to the power of 2, because there's 2 network bits. So that's 2 times 2. Or remember these guys, 2 to the power of 0, 1, 2, 3, 4, 5, 6, so on. So I can say 2 to the power of 2 is actually 4, so I get 4 networks, and that lines up. Or if I'm saying, well, how many hosts do I really get? I can do 2 to the power of, well, we got 6 host bits. So look up here, 6, that'd be 64. But I always have to subtract 2, so I actually get 62 usable hosts, because I got to account for the broadcast and network per network. Yes, it's more than 50, but that's just how the binary works out. There's no binary increment, the next one down would be 32. And do you kind of see how these numbers just seem to repeat themselves again and again? We see them, and that's how you can get so comfortable with networking, and so comfortable with subnetting, is once you get used to seeing those 8 values, you just kind of see them used and popping up in different places. All right, 3rd example. Let's go beyond the Class C. We've got 150.5.0.0, and we want 500 hosts per network. That's the biggest one I would suggest you would create. Otherwise, broadcasts get a little crazy. So let's do it. We've got 500. How many bits to get the number 500? Let's write it up. 128, 64, 32, 16, 8, 4, 2, 1. And immediately realize, as I'm writing this, we need more digits. We need more binary values because we can only get 255 with 8 bits. So we multiply by 2. We go, okay, 256, 512, 1020. I mean, sorry, I'm going a little far, but the point is we go, okay, there. That's where our first one goes because I can't subtract 512 from 500. So if my first one goes right there, again, I could find the whole binary value, but instead I look and I go, well, to get the number 500, it takes 9 bits. So I write my original subnet mask, which is /16. And again, I could use the shortcut, but I'm going to write it all out this time. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. I find just when we go to class B, class A, I just like seeing the whole thing right there. Okay, so now again, I'm asking the question, am I creating more networks, meaning focus on one, or am I saving the hosts? Save the host, we all yell. We've got to save 9 host bits because we can't get the number 9 with any less than 9 bits. Wait a sec. We can't get the number 500 with any less than 9 bits. So I'm going to go right to left. 1, 2, 3, 4, 5, 6, 7, 8 dot 9. Those 9 stay on the host side. The rest of them, is that 7? 7. Flip over to the network side. So my new subnet mask becomes a /23, which is 16 plus 7 more. Or if I was writing in decimal, 255.255.254.0. Right there. Those two are just two different forms of the same subnet mask. My increment, it's going to be that guy, who is a 2. Right? Yes, he's in the third octet, but remember, each octet restarts the increment, so he's a 2. That's fine. So now I can use that increment to find my network ranges. 150.5.0.0. We go .5.2.0, .5.4.0, .5.6.0, and down and down and down we go. Right? Now again, same trick as the last nugget. We don't want to take this through 1.0. We want to go 150.5.1.255. 150.5.3.255, right? Last IP address before 4.0, and down and down and down we go. Now, interesting enough, you might be asked, well, how many hosts per network does that really give you? Well, we look at our formula, we say, well, that would be 2 to the power of 9, because I've got 9 host bits minus 2, because we've got to account for the first and last IP address. So I'll just look at this and go, okay, this is 2 to the power of 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 512. Minus 2 equals 510 host bits, hosts that I get per network. It's almost a perfect match for what I was looking for. Okay, last example. We've got the 10 network, Class A network, that we want to break into subnets of 100 hosts per network. That's a big network to divide up into all these little ones. So first thing to do is take that 100 hosts, whoa! Little copy-paste madness on Jeremy got caught up to him. This should be host. Hopefully the previous ones weren't like that. If so, I'm sure you would have seen a little bubble because I'll go back and add a bubble there saying I really meant hosts. So determine the number of hosts and convert that to binary. So I've got 100 hosts that I'm going to convert to a binary number, 128, 64, 32, 16, 8, 4, 2, 1. And by the way, the more and more you do of these, the more you'll get to the point where you just kind of look at them. Do you kind of, I mean, again, remember, it's 8 numbers. It can only be one of 8 numbers. So when you see 100, you may get to a point where you don't even have to write that up anymore. You just look at it and go, oh, okay, well, that takes 7 bits. I know that 128 is the 8th bit, so it's going to take 7 bits to do that. So again, you'll just get faster and faster and faster at these as you go, just to give you a good guesstimate for you. I would suggest, before you take the CCNA exam, that you should be able to work through one of these guys in 5 minutes. I know, that's aggressive, but 5 minutes I think should be the maximum amount of time that you spend on doing an entire question like this. That's kind of the speed level that you need to be at. Otherwise, you might run short on your CCNA exam. So we've got 7 bits that we're getting. Reserve bits in the mask, so I'm going to say a /8, that's a class A, is 1, 2, 3, 4, 5, 6, 7, 8, dot, and then you want to write out all the zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Because you've got to be able to see where these lines are being drawn. Okay, so are we creating 100 networks? Is that type 1, or are we creating 100 hosts per network? We're hosts per network, so save the host bits. We're going 1, 2, 3, 4, 5, 6, 7, and then 1. He flips over to the network side. Now, whoa, wait a second. What about all the rest of them? They all flip. That's my very fast writing. They all flip over to the network side because we graduate ourselves from a /8 all the way down to a /25, as in all these become subnets. So what we get is we get fairly small networks, 100 hosts per network, and a whole bunch of them, a whole bunch of these bits. Now, you might say, well, good grief, that would be what? 2 to the power of, we added, that'd be 8, 16, 17 subnet bits to figure out the number of subnets. Are we going to figure that out? First off, they're not going to ask you that on the exam. Cisco is not cruel, often, to ask you a question like that. What they'll do is they will, they'll ask you something that you can figure out just by multiplication. What I would do if I got this is, let's go to scientific. Yeah, there we go. So we can actually do 2 to the power, that's x caret y, 17. Equals 131,072 subnets. Is what that this little scheme gives us. So we've got a lot of networks that we can grow into. So we go, okay, that's good. We've got our subnet mask. If we want the decimal version, it's 255 dot, what's that last one? 128. That's a new one. We haven't seen that one yet. So those are 2 different ways of writing our subnet mask. Our increment happens to be 128 as well. It's the same value as the subnet mask. It's one of those rare circumstances. So now I can drop down and figure out my increments. 10.0.0.0 is what I was given. That's where I began. My increment is in that last octet, right? So it's going to go 10.0.0.128. 10.0.0. Now what if we add 128, we get 256, right? No, we can't have that. So this goes back under one of those rare rules. I shouldn't say rare. One of those rules to where, let me fill in the end ranges. I'll go, this goes through 127. And if this was 256 down here, this would go to 255. So I just have to say, okay, well, the next one then starts at 1.0, 1.128, and then 2.0. And then 2.128, and it just keeps going down and down, and fill in the end range. This goes through 127. This goes through 255 through 120. Do you see the trend? So this I needed 100 hosts per network, and I ended up getting about 126 hosts per network. So, essentially 2 to the power of 7 minus 2 it gives us the number of hosts per network, and that will give us our network ranges. Now, of course, I have homework that I have the written answers to, where you can download them from CBT Nuggets and get the answers to. But let me just make a broad statement. Like, this is what I would like you to do as homework. Let me make a broad statement. At this point, I would hope that you're feeling pretty warm and fuzzy about the 2 different styles of subnetting that we've talked about so far. And I say that because really, it's one style. It's kind of the same 3 steps. I'm just slightly tweaking it as we've gotten into this nugget and given you a number of examples that we've walked through. If you're not feeling warm and fuzzy to where you're kind of like, it's still, I don't quite get it, I would seriously suggest running through those nuggets again. Maybe just bounce it off somebody. Have somebody watch it with you. I will find sometimes just talking through my questions with somebody and just be like, when you get to a point, even if the person has no idea, if you're married, this is the best thing for your spouse to do if they can help you out. If just have them sitting next to you and be like, okay, let me stop it. When Jeremy said that, what did you understand? Did you get that? Because I will tell you, sometimes even somebody that has no clue about networking will be your biggest ally to just talk it out loud with them. I will tell you some of the most whacked out network situations I've been in. I'm sitting here, as when I talk to you right now is how I am most of the time. I'm just always, I'm thinking out loud. I'm pacing around rooms. I'm like going, okay. So if I got this, and I'm like, I don't get it. Why is this not? It should be working. And it's God sends her in, I believe. My wife always walks in the room at just the right time, and I'm like, and she's like, what's going on? I'm like, it's just a network thing. Don't worry about it. And she's like, no, tell me. And I'm like, Oh, because I know she doesn't know what I'm talking about. But so I'm like, okay, so I've got a computer over here. It's not talking to the server. I don't know why. I mean, he's on this summit, and she's just like, and she might just be like, so can he surf the internet? And I'm like, well, yeah. I don't. That's okay. Hey, okay, go away. I'm like, I've got it. Hang on, wait a second. And so a lot of times she'll just talking it through with somebody who may not even know a thing about networking can sometimes help you out. So I would really encourage you to do that, and then chalk through these 4 problems. So 2 styles of subnetting you now have down. We've got subnetting based on the number of networks, and then subnetting based on the number of hosts per network. 2 more to come. That would be reverse engineering a subnet problem, and then the ultimate, the pinnacle, variable length subnet masking. I hope this has been informative for you, and I'd like to thank you for viewing.